A federal scientist released a report estimating that the size of the Gulf spill had surpassed that of the 1989 Exxon Valdez disaster, making it the worst in U.S. history. But the full extent of the damage to the environment is only slowly becoming clearer, with many questions still unanswered. We get more on that now from David Hollander, professor of chemical oceanography at the University of South Florida's College of Marine Science. Professor Hollander, welcome to you. I'd like you to start by explaining to us the discovery by your team of scientists of a plume of oil below the surface. Now, what does that mean exactly?
Yeah, so first of all, I'd like to clarify the vision of having this dark crude oil plume in the subsurface is not at all what is actually going on. What we're seeing in the subsurface is actually something that can't be seen. The hydrocarbons are actually dissolved in the water, so the hydrocarbons which are actually in the water itself are invisible. In other words, they can't be seen, but they are easily detected by our sensors, which can detect organic matter that is dissolved in seawater.
And what
we were able to see.
No, go ahead.
Go ahead.
Sorry.
I was saying we were able to see this dissolved organic matter in the water down to a depth of 1,400 meters all the way up to the surface with a maximum below the surface at 400 meters. And this is quite extraordinary to have that kind of dissolved organic material in the water column, specifically hydrocarbons. A team of our researchers were 15 kilometers to the east of the well site the year before, and they had no detectable dissolved hydrocarbons in the water. So this finding is significant.
Now, these dissolved hydrocarbons are said to have an insidious effect on the ecosystem at the surface of the water. Tell us what impact does it have, and what's down there being impacted?
Well, I think the context of insidious was meant that was put in the context that the surface. One effect of the spill, of course, is the surface response, where you see the degraded oil, you see the oil sheen, and it's something that's trackable, something that where you see it, you can clean it. This is insidious in the sense that it is invisible. It can't be seen with the naked eye. You need instrumentation and you need analyses to be able to see this. So the impact of these dissolved hydrocarbons in the subsurface ocean is obviously something that we're tracking. Its influence depends very much on what is its concentration. So all of these sensors where we have detected, which we have used to detect the hydrocarbons, are also complemented by physical water samples, which are being analyzed in the laboratory as we speak, and we should have results to confirm these findings within 2 weeks.
What do you worry about? Give us a sense of the ecosystem that you're looking at, and what you fear in terms of impact.
I think our largest fear of impact is if indeed these dissolved hydrocarbons are actually able to get to shallower depths at high concentrations, such that they're at 200 meters or 100 meters and are able to actually impact the continental slope, impact the continental shelves. And that is in particular where there's a lot of habitat for fisheries. And that is also a major consideration is when you have these dissolved hydrocarbons, they can have a toxic effect, especially on small organisms like phytoplankton, like fish larvae. So one of the effects could indeed be just a toxic effect, it being too toxic for them. The other effect is a little bit more subtle and perhaps a longer-term response is that these dissolved hydrocarbons can be taken up by bacteria and phytoplankton at lower concentrations, and then they can be essentially through the food web, they can cascade upward so that upper trophic levels eventually accumulate these hydrocarbons.
Now, this isn't normal for oil spills, correct? For the oil to remain under the surface, to be invisible, to dissolve like that. Are there theories about what's going on in this case? Is it because of the depth that it's all happening at?
Yeah, I think there's two current theories about why we would have such large subsurface hydrocarbons. Of course, most oil spills are two-dimensional spills where it's coming from the surface, a ship failure or a pipeline failure. But this, where there's a blowout at such great depth, there's a natural process called emulsification where you can have a reaction at high pressures between the gas, the seawater, and the petroleum, which could actually create sort of an oil-water hybrid, which behaves not like oil but behaves more like water, and could essentially become neutrally buoyant in seawater. In other words, it could be residing stably in the subsurface. That's one hypothesis. Another hypothesis is that with the use of dispersants, which essentially are a cocktail of organic solvents and detergents, with the unprecedented use of the dispersants at great depths, and I should comment that these dispersants are used very effectively on surface oil for appropriate applications. It's exactly the right thing to use. But the application of these dispersants at great depths, we do not know the physical chemical interactions that were actually going on with the dispersant relative to the oil. But one can envision that utilizing the organic solvents in the dispersant as well as the detergents, one could isolate hydrocarbons, low molecular weight hydrocarbons, small organic molecules, but certainly a portion of the crude petroleum can be isolated, removed from the crude oil, and actually the detergents then can enable it to become dissolved in the ocean.
And let me just ask you very briefly, how long before we know the extent of the damage here? Briefly, if you would.
Oh gosh, I think it's a question of can we track this? Can we continue to get a sense of what is the nature of this subsurface? What are the nature of the subsurface hydrocarbons? What hydrocarbons exactly are we observing? What is their distribution? What is their abundances? Is really quite critical. But we need to be able to go out there again and really make a concerted effort to begin to understand this undersea volume of the component of the petroleum spill.
Okay.
Again, it's widely recognized that the volume of petroleum seen on the surface does not compare to the volume that is coming out of the broken wellhead. So there is a large portion that is still missing.
All right. David Hollander, the University of South Florida, thank you very much.